Hello everyone. In today's session, I'll be explaining about an ARM code which is used to find the largest number among an array of numbers. Okay, but one thing that I want it to be clear now only, the numbers I'm considering here are unsigned numbers. What do you mean by unsigned numbers? Unsigned numbers means it includes only 0 and all positive numbers. Okay, negative values are not considered here. Okay, if you have an array of signed numbers which includes positive and negative value, in that particular case the code will change. Okay, fine. Let me just continue with this now. Okay, let's see what's happening here. These are assembly directives. Area instructs that a specific segment should be given in the memory to store this particular instructions. This is a random name. Code informs that these are instructions and not only just data values. Read only informs that this particular code should not be modified during a runtime. Okay. Entry indicates where exactly the code is starting. Start is a label. Then now let's move to our actual code. Okay, let's assume this value 1 being a label. Okay, it has all this data stored here. Okay, so we have DCD, which is nothing but instructs that this is a 32-bit value. All these are 32-bit value because DCD is written here, and you can see 4 different values. So we want to compare the 4 values and we are trying to find which particular number is the largest. And let me just repeat that these 4 are unsigned numbers. Okay, all numbers greater than or equal to 0. Fine. Now let me just see what's written here. R5 is a counter. Okay, if 4 values are to be compared, I'll be specifying the number as 3. Okay, because one value I'll have already taken it in one of the registers. Okay, so that is what this R5 is. In R1, okay, I'm storing the address of this particular label so that it's easy for me to access all these contents. Next instruction is LDR R2, content of R1, #4. Okay, what happens here is R1 will be pointing at this table because it is DCD. This occupies 4 memory locations. So this content is copied and it is put into R2. Okay, and because there is #4, what happens is the address stored in R1 is incremented by 4. Okay, if it was 16-bit data, 8-bit data, or whatever is the exact bits of this particular data, based on that this particular instruction will depend. In our case, R2 register holds the very first value. Then what we are doing is we are loading the next value in register R4. How are we doing that? Already R1 is incremented by 4, means it will be pointing at this particular memory location. So that content is loaded into R4 and again R1 is incremented by 4. What that will do? It will make sure R1 is currently pointing at this particular location. So that is for the next loop, but as of now that is not required. What we should know is by this and this instruction, we have made sure first value is stored in R2 and second value is stored in R4. And throughout the procedure, we will assume that we want to store the largest value in R2. And our initial assumption is that our very first term itself is the largest value. So when you compare here between R2 and R4, internally what happens is R2 value is subtracted with R4, that is 3, 3, 3, 3, whatever 3's are here, minus A is carried out. Okay, and based on the result, okay, because comparison is happening here, okay, automatically flags are set, conditional flags are set, and based on which branch operation is carried out. branch hi, okay, that is nothing but if R2 is higher than R4, in that particular case, you will branch here to loop and just counter value is decremented and you will go back into the loop, because we want our final largest value to be stored in R2. Okay, because if it's already greater than R4, we don't have to make any change. But if it is not the case, if our R4 is actually greater than R2, then that value is now shifted to R2. Okay, fine. After any of the cases, whether R2 is greater or R4 is greater, if R4 is greater, we are copying it to R2. If R2 is greater, we don't have to make any necessary changes. Then we will directly go and subtract, R5 value, which ensures that, okay, out of 3, already one comparison is done. Then we are branching back to loop, okay, because R5 doesn't become 0 immediately. Fine. So in this loop, we will take the next data. Our next data is nothing but our 8888, okay, that is copied to R4 now, okay, and then we are comparing R2 and R4 again. Our R2 will be nothing but out of 3 and A, which is the highest one, that will be now stored in R2. In our case, because this is a higher value, now this will be compared with 8888, okay. So after that, if you notice this R2, this will be R4. R2 is still greater than R4, okay, because of which again it will come here, it will subtract R5 and again go back to the loop. Next value, that is 9999, will be copied to R4, okay, and will compare A with 9. And since again our R2 is greater, we will jump here, okay. Subtraction is done. Now result will be actually 0, because of which we'll go to the final step, wherein R0 is made to point to result. Okay, if you notice here, I think I have not explained this part. Assembler directive instructs to create an area in the memory. Okay, this is a random name, and data here indicates that this particular statement, it actually holds data values and not instructions. Read write, because after all the instructions are carried out, we want to store the result in this particular location. If it is a read only section, we can't make any modification. Okay, then let's see what exactly is happening here. R0 register is made to point at result. Okay, and then whatever is the answer there in R2, we are storing it in the address pointed by R0. Okay, stop, branch, stop. This is an infinite loop. Now let's see how exactly it works. So R5 has the initial counter value as shown here, and R1 is pointing at the address of value 1. According to this, value 1 is our memory wherein all the data are stored as 0x0030. Okay, so this is how data is stored in the memory. Let's go ahead with loading the first value. As you can see, R1 was initially pointing at this data, so that is copied to R2. Okay, and then R1 value is incremented by 4. Initially it was 30, so plus 4 is 34. Then you are comparing R2 and then you have taken the second value, okay, using this particular command, wherein R4 is now loaded with R1 content, which is AAAA, and next step is your actual comparison. If you find the instruction BHI or branch if higher, it always checks 2 flags, one carry flag, one more Z flag or 0 flag. Okay, if in case carry equal to 1 and Z equal to 0, in that particular case branching occurs if BHI condition is written. Okay, and if you are considering the case of comparison, let's assume compare R2 comma R4. Okay, and then if branch if higher is written, what internally happens is R2 minus R4 happens. Okay, and if in case R2 is smaller than R4, then there will be borrow, correct? That is what happens in subtraction. But how exactly carry flag gets affected by this? If there is a borrow, then carry flag will be equal to 0. If there is no borrow, then carry flag equal to 1. So if R2 is greater than R4, in that particular case, carry flag will be set as 1, else it is set as 0. Okay, so HI, higher condition, always checks carry flag and Z flag. Okay, but R2 is surely less than R4, because of which we want to copy the higher value to R2. Okay, and if you see here, R2 is now changed as A. Okay, the procedure then continues, wherein R5 is subtracted by 1 and flags are set. Then we are branching if not equal to loop. So you come back here, take the next data, which is 8888. Okay, and that value is now compared with A. Okay, and as you already know, A is greater than 8 also, A is greater than 9 also. So what happens is, it will just subtract R5, reduce one more comparison, and then branch back. Okay, in this particular case, again the next value is taken, which is 9999. Okay, and that is also compared. But even after comparison, we will get to know that A itself is greater, means R2 itself has stored the higher value. Okay, so it will come back the loop. Again R5 is subtracted by 1. Okay, and now we know that R5 value, which was 5, is now 0. Okay, so it will now go to the next step, wherein it will load R0 comma equal to result. Okay, so now R0 will point to the result location. I can just copy paste it here to see what is the current value. Current value is 0, because we have stored that result should be initially 0, and then because we are storing R2 content in R0, we will get the value AAAA in R0. Okay, so that's all about finding the largest number. If in case this comparison is for signed numbers, okay, then this particular instruction will change to BGT. BGT, branch if greater. Okay, this particular condition gets executed. Okay, if Z flag is 0 and N equal to V. Branch if first value is greater than the second value in case of signed operation. N flag is negative flag, V flag is overflow flag. If both N and V both have same value, if both are 1 or both are 0, in that particular case branching occurs. Okay, fine. So let's see how that will affect the output. If this is an unsigned number, okay, then there is no doubts there. We'll just see which value is small, which value is great. But if it is a signed number, that is the MSB here, A is nothing but 1010. Okay, 8 1000, 9 1 and something else, right? So all these are negative values. Okay, while 3 is a positive value. I'll just I'll not go through that in detail. I'll just show you how output changes if this was an array of signed numbers, and if we change the command to branch if greater than to loop. Okay, I'll show you the very first case. Then the largest number would be 3333, because that's the only positive number. All values are negative here. Okay,